I'm just exporting all of my tweets. I want to see if I can get that in a JSON file so I can read it into Pharo. I just gotta figure out how to write it out in JSON. Closure. JSON. Is it write string?
Yeah, and that's the other thing is I feel like I'm probably doing it all wrong. You know, that's why I'm glad he's here, because he could show me the happy path.
Yeah. Yeah. Super fun. And by the way, I actually did watch the whole thing, and it was what was really neat was just hearing us kind of laugh in glee as we actually get the stuff running.
Nice.
It's really fun. But there's I'm not sure if I ever told you this, but what really energized me was like the mystery you put out there into the universe. So like, how could they write, Smalltalk on the Altos and 180 lines of code?
180 pages, yeah.
180 pages of code, and it is there's some parts that are just even in the couple of hours I spent, there's some things that are just bordering on revelatory. Or just the fact that, like, how much isn't it awesome that you can actually just pop a clock in the middle of your dev environment? And the fact I watched one of Tudor's video from like 2014, and the stack is a Smalltalk object, and you can serialize and send that somewhere. I was like,
so cool.
And I thought I was ready for radical ideas, but holy shit, that's a pretty radical idea.
Yeah. Everything's an object. Like, you're serious.
So yeah, when he was showing this demo of like the web server running, inside Smalltalk, and someone in the browser, and basically there's a increment and a decrement button, and if you decrement past 0, it throws an exception. And there's some guy in the audience like, oh, you can't run that in production. Kind of completely missing the point. Right. That the point isn't that you would have a manual exception handling process. The point is, like, you could
do it so quick, and like whatever you needed, you just build it right away.
Yeah. And you're stopping the world while you figure out how to handle the exception, and then presumably, and then he fixed it, let the program run again, and it's like, okay, you can now display -1 without throwing an exception.
Right.
The world paused. You fix things up, and then kept going.
That's
that
so
was
cool.
Wild. All right, I'm gonna get this right string.
Yeah, I think there's something missing in the, hey Tudor, there's something missing in the sort of discussion about languages and their properties and how, which one is better, that kind of discussion. There's something missing about the dynamism. They're always talking about like, what does this language give you in terms of like, oh, this is more expressive or whatever. Yeah, but like, can you run it and like interact with it while it's running? And maybe you don't need a cool feature because you just have that mega feature. Gives you everything you need.
Hey Tudor, I just want to say thank you so much for all this help. This has just been
for sure.
Tweeted out like actually having fun building some things now that I have some idea of like what to click on, what to type, some knowledge of the syntax. And I was telling Eric, I mean, I was just jaw-dropping seeing that 2014 talk of how everything's an object, everything's inspectable, and like even the stack is an object. I thought I was prepared for wild ideas, but I was not prepared for that. Just pick up your stack, send it someplace, and presumably unserialize it and put yourself into the. What do you need to run a program? The stack and the heap. So you can't really. Well, I mean, how you can't reconstruct the running state, but you can look at the stack, or can you create the running state?
Is it really a stack, or is it just call frames that are like maybe a linked list or something?
Well, that's what the stack is, right? But the recreating the running frame would require an omniscient debugger that basically would, if you would store that, you would be able to reproduce the running state then.
Say that again. So you need the stack.
but you would also need the history of the execution. So if you want to bring the system in the current, in a certain state, they can be, for example, side effects. So reproducing, getting the system to reproduce exactly the same, stack, execution stack, then it would be, it's like, replaying events, right? When you store those events and you, when you're calling a service, if you want to be able to reproduce that service with exactly in the same state somewhere else, you need to have the history of all the events that have been sent towards that service. So here you would need an omniscient debugger, basically, that would be able to record everything that is relevant for the current state. And then you would be able to replay that history if you wanted to. But this is not available.
Sure.
In well, so we did have one of the issues with omniscient debuggers is performance. So we did some research a decade ago or so, and we actually built an implementation. There was an implementation of the omniscient debugger in which we changed the virtual machine with an interesting concept of something called an alias, which didn't find in other places, but it didn't survive yet. Or it existed as a research prototype, but it was never productized.
Well, I was telling Eric just how fun it's been and mind expanding. It was really super also fun to see a slightly younger Tudor showing all the unwashed masses Pharo back in the day.
Yeah, that was a talk in 2014, I think, or something like this. Yeah. So that was right after we figured out what exactly is it that we think the potential is. Yeah, that was a fun talk.
And I got in the habit of looking for the traces of Glamorous Toolkit in what you're showing. That was super cool. Hey, so I have some desired outcomes I'd love to put on the table, and some, I guess, micro questions. So I would love to get the Atom something kind of displaying. I just dumped a sample of tweets into a JSON file. I would love to be able to read that and render it kind of in that same style that you're talking about. I downloaded the new version of Glamorous Toolkit, like you said, but I'm a little afraid of like what to copy. Do I copy the Glamorous Toolkit changes and the image, or I'm afraid of wiping out all my work. It's not really a big deal, but
So now you have an image where you did some work. Presumably you created some classes and methods.
Yeah.
And everything is in the playground that will be transferred, because that's one is actually currently stored. That's a Lepiter database that is in your documents. So that will transcend images, but the code doesn't. So, but you should treat images. The image shouldn't be a place where it should be a transient artifact. It's just something you build or you get for a certain duration, but it's not something where you store anything of value. So, or at least that's how we treat it. And so if you have, for example, code, right, you want to externalize somewhere and then put it back. So a common place where people put it is GitHub, for example. So you would create a project, it will be yours, and you push there, and then you take the latest version, and then you load your code there. Like you could treat like the image, the GT image, Pharo image, Smalltalk image, you would treat it like you would treat a Docker image. So you do the work there until you figure out what you want, and then you make sure that you push towards the sources from which the image can be produced.
In fact, could I maybe share my screen, and then Eric, maybe do you want to put some aspirations on the table as well?
Yeah, I want to finish my Atoms demo, but also I feel like you shared this bouncing atoms element class, and that maybe I can do that on my own. So like now I'm not sure.
No, I would say let's do it. I was just I managed to get the demo. I managed to create the object and run the demo on
Run
it.
Yeah.
Super. Oh, this is gonna be great. Anything else?
No,
Eric?
no, that's good.
So here's the unzipped image. Do I just copy all of this? If I'm not worried about losing anything, do I just copy all of these into this parent directory here?
Leave it there because I mean it's versioned. You don't. Why move it?
Oh,
You can just run it from there.
just run from here.
I guess.
All right. So, and then I should delete the old one. I mean, kind of for tidy bookkeeping.
If it's no longer needed, then delete the old one. Yes.
Okay, I'll do that.
And I can see that you no longer have a full terabyte of available space. So you should probably delete the 50 or 100 megabytes that those things put together.
Say that again.
The Finder says that you only have 600 gigabytes.
Yeah.
So
right.
that 100 megabyte will make a big difference.
Okay, you're joking. Okay. Okay, so clean. All right. Actually, Eric, let me see if I can reconstruct what I did just to bring up the Slack. So it was called Bouncing Atom. BL bouncing.
It's a capital B.
Adam's element. Demo. Alt G. Hey. So that's great. And then what I was doing, let's see here. So if I want to see the member functions.
Member functions.
Yeah, I want to see the initialize message method
of the BL bouncing Adam's element.
Yes. So where would I?
So I was running into this as well, where I would double click on it in the playground and then hit Command G to make it like select it, and it would bring up the class.
So let's see, what do we have here? So what do you see in the second pane?
So it's the object called, oh no, it is the instance of BL bouncing Adam's element. So it's an instance, not the class.
Yeah. Okay. So, and the view that you're looking at right now, what is that?
It's an inspector window of the instance.
Right, but there's a view and it's called, if I see there, it's called raw. So what does that one show?
Presumably, I mean, I assume it's all the member, the instance variables.
Right.
So yeah, they're all variables.
So it shows all the variables and the values, right? Like what you would expect to see in any generic inspector, right?
Yep.
Good. So now we see that there are multiple tabs there, right? And we have see live, overview, preview, user data, states, resizer, styles, widget, measurement, properties, children, parents, raw, connections, print, meta.
Yeah.
Right? We see different names, right? So now you're saying the thing is that you will find raw in every object that you will inspect, because that's a view that is indeed generic, right? That's why you find it in all inspectors in the world today. because it is generic, right? So it's going to be available there. Now, another view, another perspective on an object in Smalltalk is the view of the class of that object.
Okay.
Now, which of these do you think might sound like something that goes towards the definition? Or
so I think it's
something
self
else?
because it is the BL bouncing Adams element.
Yeah, but that's self. That's like that's the same object that you see on top.
Okay.
So overview, right? Like if I look at live, what do I see in live?
I'm presuming this is the block.
This is the rendering, right? That's
yeah.
like a living thing,
Yeah,
right? That's
right.
the thing that I instantiate.
That's
right?
being
It
delivered by
renders
block.
itself.
Is that right? So this is the block.
Right.
Yeah.
Yeah, the element that you're seeing there is block. Everything is an element, and everything in the scene is that's you're in a block world, basically.
Okay.
That's the name of it, right? So we have overview. If you go to overview, let's just take a look at this.
Yeah.
So we see, for example, there's a bounds extent 400 at 300, the one on the right hand side, for example.
Yep.
Okay, so this looks like, graphical properties, kind of like things that you would expect to see when you're inspecting a visual element, right?
Okay.
Okay, now let's go to print, for example. The one but last one. There you go. So what would you think this is?
In fact, I think I saw this when sometimes I think if I did a Command P, I think I might have seen this thing. So it's it rendering itself as a string or representing itself as a string.
Yeah, this is the corresponding of S string. If you would send S string to a Java object, or is it two string?
Yeah.
It's
in fact,
two string,
it's
right?
exactly that, right? Oh, it's different. Oh, it's a new one.
Okay. No. It's the same, right? BL, it's exactly the same string that you're seeing there.
Actually, this one begins 926, and this one begins 15.
Yeah, because now you printed it. So when you printed it, you created another.
Oh, yeah. Okay. So it is a new one. Yeah. Got it.
Yep, so it is a new one, right? Okay. Okay. So what you're seeing here.
Oh, sorry. Just a real micro question. So this is now garbage. Is that correct? So it's like we just printed it, but no one has a handle to it, or like what happened to the one I just printed?
As long as it's there, it's probably going to be kept around. But as soon as that pop-up disappears, then it's going to be garbage.
Then got it. Okay, so this is a handle. This is the holding onto that object.
So if you see, right, if you go there and you say Control I, right, or even there is a drop down. There's a little drop down on the right hand side.
Got it. Okay, now I'm looking at this one.
Okay, the new one, right?
Yeah,
I was
perfect.
looking at the new one. Yeah.
Roger.
So this is that one, right? That's the default thing that you typically see printed in an object. Now, can you do me a favor? Go and press Alt click on the print. So Alt click. Right. And now go to the source, the first view. The source view on this.
Yeah.
Okay. Now let's see. What do you think this is?
This is the method. Which takes as a message a view and returns it returns whatever a view returns when you pass it a message of a text editor.
Yeah. So let's try to see what do you think does this relate in any way? Obviously, you alt click on print, so there needs to be some sort of relationship between them, right? So what you're looking at here, that's actually that method object print for, And that is actually the definition of the view print. So for example, go to the title and say print2 or something. Just change the string print in the method right there.
Stand by. Say that again.
Exactly
Change
there, right? Just do something.
Oh,
write something
got
else.
it.
Okay. So now save. And okay, that shouldn't happen. You can close this. Right. So what happened here? If you look at the view title, what does it say? On the left-hand side, right? You see print hello 1, 2, 3.
I'm not seeing. Got it. Right. In the tab.
So exactly. So which means that you have just this here is the definition of this view.
Oh, I love that you're annotating the screen, Eric. Okay, I mean, Tudor, that's awesome. Okay, got it. Yep. I saw that in your videos.
So what this means is that if you don't know what the view here does, what you can do is always alt click, because this also means this is like a legend.
Yeah.
So if you know how to read a little Smalltalk, once you know how to read Smalltalk, you can use the views that already exists around in the inspector as a way to go around through the system. So if now you know that if you press Command P, or if you look at this view over here, you get the same string. Yep. So which message do you think you should send to this object to get this string?
As something like an as string.
Now let's not guess. Let's not, as I said, this thing over here, right, on the right-hand side, that's the specification of how this is going to be produced. Right. The contents here on the right, on the left are going to be produced, right? Which means that the answer is somewhere here on the right.
Here on the right.
Right. So what do I have here? So let's go back. Here.
Yeah, got it. It's the text is print string. It's the method, the message print string.
There you go.
Yeah.
So let's actually do that. Let's try this one. So go here at the bottom.
Hey, by the way, just real quick, how I'm saving this and it's not updating the, it's updating here. Shouldn't it also update here?
Right. It should, but I got.
No worries. Okay, got it. Go down here. Well, what's this?
Right.
Whoa.
That now, that is a playground in which self, if you say self, it's going to be this object here.
Yeah.
So that's like a Lepiter notebook. And you can say self print string and now Control G or Command G, and then you have it there.
Okay, got it.
So you see all of these views that show you all sorts of interesting perspectives, right? And sometimes, like if you look at the overview view, you will see that the overview actually takes data that is not visible in the state of the object. It's composed out of some logic or something like that.
Okay.
Did not understand print string 1, 2, 3.
So. Yeah, in fact, I wanted to show you something real quick. So if I wanted to, what I saw in all the demos in Pharo is that you can create this. There's a, or maybe I do it from here. Create method 1, 2, 3. Okay, got it. Okay.
So what you wanted to say is that I can create a method inside the debugger. And last time we saw that right now the Glamorous Toolkit debugger in this specific version, but probably next week is going to be there. This specific version of the debugger does not have that function yet,
but I can do it down here
in there yet.
Yeah.
But that one is a more elaborate thing. That one is a statically inferred method. It's not, you're not running the method.
Okay.
There, right? So in the debugger, because you just sent does not understand method, so I can catch it and I know what the receiver is, I know all of it. Here, we're doing static analysis to infer that actually there is a new method to be created. So this is, for example, a difference between, so when people talk about dynamic versus static languages, right? People very often invoke the idea that if you have static typing, for example, it helps you editing, right? And that is absolutely true if the comparison if you compare two dead pieces of text.
Yep.
But if you are at runtime, so if when I'm in a playground and I'm writing, I know I have actual objects in the playground. So I don't have to infer generic types. I know a very, very concrete types. So that's why we wanted to bring a lot of the development of flow in Smalltalk. We wanted to bring it in the workspace, in the playground, not in the static code browser, because there you compete with Java-like systems, and it's not an interesting competition. So this is much more interesting for Smalltalk. And if you're in a statically typed system, for example, Haskell, right, you would want to write code in a static code browser. I don't know why, but I mean, the types help you there, right?
Sure.
So you get, it's much richer environment because of that.
That's cool. I didn't understand the distinction. I was just actually happy to be able to create the method someplace without going into a morphic world. Okay. So here's where kind of my head's at is
we still had there was an open question. How do I get to the methods?
Right. Yes.
So I wanted to tell you that basically that those inspectors that you will see, because in Glamorous Toolkit, you will literally see thousands of views. So they're literally more than 1,500 views right now in this distribution.
Okay.
And so, and they are very rich, not only by interacting with objects, but also of learning, oh, what's in this view? This looks interesting, but I don't know what it is, right? And then you can look into the specification of that view and infer, oh, what can I learn something interesting about this object? So there's like another way to have a dialogue with the object that you're having there.
So the dialogue I want to have is, I think in this Bouncing Atoms demo, somehow they create the block canvas, and I think it lives in initialize, and I want to copy that into my own class so that I can create a canvas and render a dot or a graphic.
So if you would have the patience to go through all of those views that you see on top, you will see that meta actually is the one that you're looking for.
Oh, I missed it.
And that one is
damn it, I missed it.
So
there it is.
Raw and meta and print you will find in all objects because it's just relevant for all of those objects.
Raw and
Does
meta.
it make sense?
Yeah.
And print.
And sorry, I don't mean to be impatient.
No, it is not. No, but it just takes a while, right? So here we're sometimes speeding up a bit. But just basically, I'm saying, sometimes you don't know what to do with something. Use the views in the inspector as a source of finding out interesting questions.
Yeah.
Okay. So now back to your specific target.
So in my head, I'm thinking somewhere in the initialize, I would have thought, who's creating the canvas? So it's not initialize. So in demo, is it initialize with? Yes, this looks kind of interesting. This is like a scene extent. But an atom extent, is that one?
So
no, scene extent.
What is scene extent, do you think?
So extent is size. We'll see.
You're clicking on inspect method. I don't know what you expect to see from it.
Oh, what it is. So I guess what I'm trying to figure out what it is. And so here I'm.
So let's read them. Let's read the method then.
Yeah.
Read the text.
So it's it takes an atom extent. Just leave that for now, and a scene extent.
A number of atoms, an atom extent, and a scene extent. So what is a scene extent?
Yeah, what is a scene extent?
It's an argument.
Yeah.
So there's no way you can inspect it from here because you have to pass it into a function to know what it is.
All right. This is just text. Is that what you're telling me?
Yeah. So I mean, that's the code that these some, these are just the method in that class. And
Yeah.
that method defines 3 formal parameters.
Yeah, that's interesting.
So
Actually,
you
I gotta.
did-
It's interesting that to me is an insight. Is you're saying that just this in and of itself doesn't actually say what it is. It's just text. So me inspecting it, it doesn't really yield much. Is that understanding correct?
Yeah, exactly, right.
So it is not a statically typed object that I can click into and which will tell me. So what do I?
But there was an interesting hypothesis that you had. You said, I expect to see that somewhere there is a canvas.
Yeah.
Right. That's what. So, is there any other way and any other hypothesis that you might have to?
Yeah, super interesting. By the way, if I can just have a little side conversation with Eric, like that's super interesting. That's actually startling to me that I can't like inspect it and know what it is. Like I'm not even a
Right.
Okay, so
it doesn't have that kind of inference because it might, the information is probably there. Like if you go into the size method, you could learn what is it it's trying to do with that scene extent.
You mean this here?
Yeah. So and then look, the argument for size is a point. So it's probably a pair, XY pair.
Right.
Yeah.
So if you have a visual element that somehow has size, what would you expect that thing to do?
To be passed to something, right? To make a.
Yeah, you see there you have a class called BL element, and in that class there is a method called size column that gets a point. So this one is actually, it's like a setter. It's like it would be like set size, right? Because like, but we just don't say, typically we don't necessarily say set or get.
Yeah,
you would just have size or size colon. Size is going to be a getter, size colon is going to be like a setter here.
Roger.
So you're setting the size of an element. So the extent.
Can I just backtrack in my head? So let's see here. I was looking at demo. So the demo method. Oh, they're not alphabetized. Okay, that's interesting. Okay,
they are alphabetized.
They are
they
alphabetized.
Are. Yes, but it's not. But the thing is that you have 2 sets of methods there. So if you look on the right-hand side of every method, you will see 2 little bubbles.
Oh, yeah. Okay.
One is the category, and the other one is the class or instance. So a rough approximation, which is wrong, with like the class is like a static method in Java.
Got it.
But it's not correct. It's just that's an approximation.
Got it.
So
okay.
Are
So
they organized by category?
No, here they are organized by alphabetically, but instance and class are 2.
Yeah,
they're just first instance and afterwards the class in this list.
Okay, so I'm trying to construct kind of some model of like how this thing renders itself. So in demo, it initializes with 300. So number of atoms, got it, of size 5 by 5, which I guess is the size of the atom, within a canvas of something of 400 by 300. So inside of initialize with, Eric brilliantly pointed out, what is someone doing with the size? Right, that's self size. Okay. Now you're adding atoms. So you're calling the method create atoms. Presumably this is going to create an array of atoms, a collection of atoms. Within.
That is, what is the name of the method that you just expanded here?
Yeah. That was a question. You just asked me a question. Let's see here. Hang on. Within?
No.
No, right. That's the message.
Actually, can you just click where within is? Just click there. No, where in the word within inside.
Oh, click in here.
Right. So what's the method?
Oh, it's all
What's
with
the message name?
Yeah. Within is the message name.
No, it's add atoms : offsize : within : that's a single message sent to self with 3. So it's a message with 3 arguments, and you see the definition below. Right. So these are not 3 different messages sent to self. That's exactly 1 message sent.
Got it. Oh, got it. Yes. Okay. This is what's being passed to as a first argument.
Yes.
And so I've got it.
One, and then that's the third one.
Got it.
Mm-hmm. Let's take a look at. There's this interesting thing.
Oh, no. Yeah. No, I'm just confirming. This is the third argument, a scene extent, which comes from
exactly.
Yeah, and so which is this. Okay. All right.
But actually, can you go back into the first one? So what do they pass? Because that add atoms, isn't it an interesting thing?
Yes.
So what do you think is in there?
I'm going to infer that it's going to be somehow this creates a collection of atoms,
right.
Atom objects.
Okay, now we need to take a step back. So this is how you would read Java code. That's exactly what you would do. You stare at the code and you infer as much as you can. No, it's a way of doing things, right? And because the actual playing with the code is so far away that sometimes a reasonable strategy is simply read through that piece of text. But now we have something, right? We have a hypothesis. We have something that is simple to test now. So first of all, there's a self new atom that I could maybe take a look at. I don't know what that times collect is, right?
Yeah, actually, I was where my head was going is I would like to make a new atom. Can I do that?
I'll try.
Yeah.
But wait, you're already 2 steps now ahead. So don't do that.
Don't do this.
This is a context. This is a context. When you go here, you already generalized a bit, but don't generalize. Be very, very specific. So here, whether you're writing self atom, new atom here, or you're writing it here, it's actually the same thing. So you can actually go and select this one and see what happens.
Okay.
Select, and then you do Command G. You should select the whole thing. And you do Command G, because that's itself. And there is a single unary message. So there's no arguments that need to pass.
Yes.
So now you have something. So what did you get there?
I got a red dot.
You got the red dot.
Yeah,
but what is the red dot? What instant? What class is it?
It's a BL atom element.
So are they kind of the same? I mean, so if I look at the superclass of each of those, what do I see there?
It's a BL element.
Right. And then it's also a BL element. So you were assuming that you have a canvas on which you draw, right? While here, it seems to me like maybe BL bouncing atoms element is composed out of little atom elements, which is a different hypothesis. Right?
Yeah, holy cow.
But do you notice here how the process of discovery is different? That's what you need to focus on first.
Yeah.
The first thing you do in any Smalltalk environment is learn how to learn.
Love it.
In Glamorous Toolkit is even more so.
Now I'm very curious what happens if I make 2 of them, if I make a collection of 2.
I don't know, but we still don't know what this one does here, right?
Okay.
Now it would be great, interesting to see what this one does. So what would be an interesting small experiment to try to see what does that one do? Now let's see, why would this not work?
Why would that not work?
What's the receiver of this?
Self.
What's the receiver? No. In the thing that you selected, what's the receiver? You selected a piece of text and you say run this.
Yeah.
So what
I
is the
thought that,
receiver?
oh, it's not defined.
It's not
At the
defined
receiver there.
because that's right, because
Yeah.
a number of atoms times collect colon, and then I have a block, and in the block I have create a new atom.
Was sent to
Then
nil.
that was sent to nil because that's an argument in that thing, and there's no, you only have self there.
Yeah.
You don't have anything else in an inspector, right? So that's why you don't have that. So, but a number of atoms, what do you think that is? Because we kind of traced that one over there. So what was that? How many
Right.
atoms did we have before?
300.
300. So could we write here something that kind of does what we want?
Ah. Okay.
So what does times collect do?
Iterate.
Yeah.
Something.
Now let's quickly expand it.
Nice.
Right, so it says 1 to self, where self is the number, right?
Ah.
So 1 to self, and then collect, and collect is like map. Similar.
Right. And then
So
here's
you have a collection of 3.
some sort of bound variable,
Yeah.
and then stick it at the slot of an index.
Yeah.
Okay.
Make sense? No?
Yeah. Okay. What made sense? Yeah. Do I understand what this does now? Okay. Yeah. Okay. You got it. Yes. This is the number, and we're just creating a collection of elements, new atoms.
Yeah.
That are all of the same superclass as.
Yeah.
Okay. A block element.
Yeah. So element by element, you can think of it like like a DOM element. So they're all DOM elements.
Okay.
Okay. Now let me propose a different way in which we could explore the same problem. Okay. So there is a view in there which is called children.
Yes.
So what does that one tell you now?
There seems to be like a hierarchy of these are all children of this.
Right.
Yeah. In fact, I guess so. I'm guessing now that this is actually the Uber DOM element. This is the canvas of which is composed of.
No. Ah, okay. Take a look here. Let's again, like let's read, right? What does it say? It says preview, and this one is
the type.
The type. And what's the type of this one?
It's a block bouncing atoms element. So
which is
the equivalent of like a DOM element.
No, it's this one.
Yeah. Okay.
Because we are looking here. This is a view
Yep.
of this. So
Okay.
if you're looking at the children of that, then we are looking at this one is the root, and then the children you're expecting to be underneath.
Okay.
Okay, let's go another way in which we could possibly look at the same problem. So let's go on live here.
And Eric, feel free to break any time. Yep.
So press like this, Control, Option, Shift. And now click. So let's explore that thing. Let's explore what we see on the right-hand side. Let's scroll a little bit up and down here.
Okay. Oh, holy cow. It's like it's like the in a DOM browser.
There you are.
Yeah, okay, got it.
So here's what is now interesting. Those things that are moving on the scene, those BL atom elements, are actually just normal plain things. So the green thing is not a canvas on which you just draw something. It's you literally can go and click on those things.
Yeah.
If you click on the object, not on the name. Yeah. So click on the BL atom element, for example.
Okay. Yeah.
Does it make sense?
Yeah.
It's interesting that this one appears to be blue. It should those things should be red, but that's
okay.
It's going to be confusing.
Yeah. So this is a little.
So what you're in here, anytime you're in any window, you're going to have a very large tree that renders the whole scene. That's what we understand by something we call a one rendering tree.
Okay.
So all the time when we are in Glamorous Toolkit, we do not put canvases in canvases, you know, iframes in iframes or canvases in iframes or whatever, those kinds of things. We just have a single abstraction that can render everything, including visualizations or widgets and text, and then we can mix and match those things in arbitrary ways.
Okay.
So let's go and now let's do. So one of the things in the demo of the atoms is that we change the color of a single atom.
Okay.
So how would you approach something like this?
Yeah, I would grab one of these and send it a set color message.
Mm-hmm. But just for the sake of brevity, we call it background. No, color.
Is the self?
It's not set color. It's called background.
Roger.
It's not set, it's background.
Oh, sorry.
Because it's a message, it's going to be with the small cap. Okay, and what you pass to it is a color object. So let's say, for example, color, you have to do something like color, capital C. And then, for example, blue. Blue.
Not the string.
Send a
blue.
message. Right.
Just
no, obviously, because that string is red. Oh, you know this game.
Joke.
Red. Right. Red, there is this. What is it?
Ah, hey, look at that. Okay, cool.
Now run it. Now run it.
Right. Now if you do it.
Oh, okay.
Right. It didn't. The view on the left didn't update, but if you when you inspected it again, it updated. No. So let's escape from here. Actually, wait a second, just to make sure. Let's also give it, because remember that we have size, maybe because we don't see it properly on the left-hand side, right?
Yep.
You don't see where it is. So could you go there and then do another, Command Enter, you can do.
Yep.
Command Enter. either at the beginning or at the end. Yeah. Okay. And then you can do, for example, self size. And you can do here, so colon, and remember that one, one to the point, right?
Yeah.
So you can say, I don't know, 20 at 20. No, just say 20 at 20. Nah, that's a bug. Yeah.
You
Okay.
need the at sign.
There's an at.
Oh, that's right.
There you go. Let's see what happens. Do you see it on the scene now?
Oh, look.
Oh,
it's on the
hey.
left. The big blue one.
Now you can get out of it. You see here the name of it is called Glamorous Scene Driller. Right. So you're like in a meta view which you're expecting the current world. So you can exit. You can here on the top right, you can X.
Oh, got it. Okay. Ah, okay, got it. Okay.
Now you can make a game. You can make it try to click the big blue square.
Yeah.
Okay.
Cool. I don't want to stop you if you're learning.
No,
keep going.
this is great. I'd love to turn it over to you. Although still the question back in my head is like, okay, I want to create my own where I can assign a X and Y coordinates or something, and I want to render one of those. And I'm not quite sure if I know how to do that. If I had to start from scratch. But Eric,
maybe,
do you? Yeah.
Maybe I'm doing similar stuff, so maybe you could watch.
Yeah. Perfect. Yeah, I can't. How about I turn it over to you?
Yeah.
Okay, great.
Okay. Y'all see it?
Yeah.
Yes.
Wait, what are you seeing?
I see.
We're seeing BL element.
Okay, cool. Make sure it's the right screen. Yes. So I feel like I'm having a lot of UI issues. So I wrote some code, and I found workarounds for everything I needed to do every time I got stuck. And this is where it's at. I can draw stuff.
Eric, this is awesome.
I can't make them move. I stopped before I figured out how to make them move. And I was trying to find examples, and I somehow had never found that BL bouncing atoms element. Even in the search, it never came up until I knew the exact name of it. So I feel like it's UI issues like that where I don't know if it's the paradigm, I'm using the wrong paradigm for the UI, or if it's a bug or what. Can I just show an example of the kind of thing I'm talking about? So I'll go here, okay, I'll add a class, and okay, I click on it. Oh, I have to double click. So I double click, and then I start typing. Let's say I want to type Eric. Oh, my thing is already in there. So, okay, that looks good. I hit tab. Oh no, but that's the same class I already have. So I don't know. I feel like I spent hours trying to get the class created. And so I'm going to do Eric, I'm going to call it open. I'm like, okay, great. And I can't save it.
That happened to me.
What am I doing wrong? And I somehow did manage eventually to get it, but I don't know what I did. And I feel like I'm missing something, because I did get it. And then I tried to do it again, and I felt I've spent another 10 minutes trying to type in this one class. So what am I doing wrong?
Oh, can I just riff off of that? So I opened up Morphic World and then managed to create objects, but I'm not seeing what I see in the demo videos in the tutorials. So yeah, I had the same problem, by the way.
And so I feel like there's something I'm missing that if I just knew it, I would be much faster and be able to actually learn something sooner. So what's going on?
First of all, fair comments. And so what you're seeing here is our attempt to try to put some structure into creating a class. Typically in a Smalltalk world, or classically in Smalltalk, you create the class by simply sending a message to the superclass. So if you
I tried that too, and it didn't work. That was the first thing I did. I was like, okay, I'll find some existing Smalltalk code that's not in a browser, that's in just like, here's how you make a class. And I pasted it in, and
pasted where?
In a playground.
Yeah, that should work. There's no way it doesn't work.
Yeah,
because that's exactly what happens here behind the scenes. But what you're missing here is the name of a package. In this case,
the name of a package. Okay. So if I put the name of a package, I have my own package, and now I click.
Just press enter, because it would.
And then it's stuff like this. Like now I'm like, okay, I got to start over. I remember I can do Eric open, and then I have to press enter. Okay.
Yeah.
I see. Because I was trying everything I know, like, okay, I don't want this one, so I'm going to click away.
Then you have Eric right below it.
I have Eric right below it. So I need to touch the mouse.
You don't know. You can just say escape,
I just hit enter.
Example,
escape. Okay.
Right. Because
okay.
it's completion.
But I still can't.
Enter.
Then I have to hit enter. Okay.
Right.
All right. And then it changes. Okay. So it's okay. I thought I needed a tag. That's what I thought.
So tag is a less fortunate. The package tag is a less fortunate structure. You can think of it as like a package structure with just 2 levels of nesting.
Okay. Okay.
It shouldn't have been like this, but it is like that.
So I have my demo. Can I say one more thing? Like these are the things I'm aware that it's either a bug or a problem on my end. So if it's my end, tell me. If it's a bug, maybe it'll help to fix it. But like, you see, I have these 2 class methods that are exactly the same. The reason is because I can't figure out how to get the play and inspect button to activate on this one, but I can do it on this one. And I've closed it, and I've run it. I can run it, no problem. I can hit this one, but
what happens if you're?
It's just deactivated.
That shouldn't be. I don't know.
And so I just was like, well, I'll make a new one that's exactly the same code.
My suspicion is that you actually, is it possible that you have an inspector somewhere, or
like one already running? So I did have a bug in it somewhere. Like it wasn't in this code. It was in some of the code that it ran, and it opened the debugger. I closed it, and then this had been deactivated ever since.
And no, it actually, every time you click on that one, it's going to deactivate and activate when it gets back control. But if something happens along the way,
how do I know if I have another window, another inspector?
No, it's maybe on a debugger or something, and maybe something got confused along the way. Like,
is it like in another? Oh, is this it? Oh, look at that! It was in another window. Let me see. Does that fix it? Wait, Eric Adams. Yes, it's back. Okay. I don't know how much time I spent on that trying to figure out why I couldn't do it. Thank you. Okay. That's good to know. So like what I feel like is when you're there is a very happy path. And then once you're not there, I'm clicking and nothing is doing what I expect it to do. And I'm looking like it's not even like there's something to look at. There's nothing to inspect, because you know what I'm saying? So I feel like I still need a bunch more knowledge about how to work before I can really feel confident in it. So I'm glad you're here. Thank you.
But this is awesome.
First of all,
sorry.
First of all, thank you for the patience, right? So these are clear. They're clearly UI. So they are clearly UX issues, and these kind of sessions are very useful for me as well, because I get to learn, what works, what doesn't work in the designs we do, and everything. All of these things are addressable, or we can augment those, like the UI with just the input that we have from here. And so we already have a significant list from the previous session, and now we are adding some new things to that list, which is great.
Cool.
So,
awesome.
Thank you for doing it.
You're welcome. But yes, I did get it.
This is amazing.
Somewhat working. I do have to say, I mean, another thing was I'm using the, where is it? In the Atom. So I'm using this transform do because it just seemed like relocate wasn't working. But I don't know if that was because something else wasn't working. Like I have an animation and I have this repeated task action, and I don't know why it's running tick, and I've got run, and I don't know where to find out more about how to use this thing when I bring it up.
Okay, so how do you learn about something? You look at where it is being referenced.
What?
Yeah, but yeah. So one way to learn about something is you're looking at it. Another way to learn about something is to see how people are using that something.
Right. Okay, so I could search for it in here. That was the first thing that I would think of. So I get the class, which I already have looked at, and it's just got 1,000 methods, and I don't know what they do. So subclasses, superclasses, and new page. Create a new. No, I don't want to create a new page. So now I'm lost. I don't know where to go from here.
So another way to look at something is to look at references to that.
That's what I'm trying to find in the search.
Right. So the way you look at references.
Sure. Sorry.
No, it's okay. So the way you look at references is by is you can click on it and then you say, so references is one way. Another way is to simply go on the left hand side, so where the thing that you want to look at the references, and you press Command N. It's not yet in the menu. So notice here how you get a search reference filter.
Search references filter. Yeah. Okay. And so it's the same methods that I saw in the other list. Yeah. Okay. So I see my reference here. That's cool. So brick.
You also see other things in monitor.
I'm gonna look in the brick. Ooh. Okay. Where is it? There it is. New delay 500 milliseconds. I seem to remember looking at it and it had a delay already. I didn't set a delay. It was like a default delay, but I'll set it. Action. Would you explain the yourself?
Okay, so what is yourself? What do you think yourself is? So
it's a message.
It's a message. So let's if you see a message, let's see where it's implemented. The way we look at implementers, so N was for references because there's N somewhere in reference. and
I'll never forget it now.
There you go. And so you just have to spell the references and then try all of them.
References.
Exactly. It's clearly important. And then another one, right? It's for implementers because M is in there as well, right? So
is that option?
Command M.
Command M.
Command M and Command N. Okay.
It's an object. Okay.
Right.
So
let's see what's the implementation.
Self.
That is.
Well, so why? Oh, look, it has a bit of explanation. It does deserve a bit of explanation. All the cascaded messages are sent to the receiver. imagine that. Oh, so what does this message return? Because it would return whatever this one returns if you didn't have the yourself. Is that right? How do I get the inspector to come up for this message? It doesn't know, does it?
What would you mean? What do you mean by inspector?
So
The
like
inspector is
on,
for,
sorry.
inspector is for objects.
Okay, so I have this little arrow that I can open for this message.
Right, that's a browser. That's a code browser.
A code browser, okay. And it's on a lot of them, but it's not on this message, and it's not on this message.
That's actually it's just a little bug because we could resolve it because the receiver is quite obvious there.
Right.
So we can extend that one to also hold that.
Right. I notice it's not in the cascaded messages.
Exactly. The cascading has a little tiny issue there, but we could extend it there.
So is there any way to even see what this is right now? Could I?
You remember which one is it? N or M? What do you think?
M. I'm just wondering if it works because
But just a second. No, because this is an interesting point here.
Okay.
So what kind of implementers are you looking for right now? What would you like to look for?
I want to look for whatever this returns, which I'm assuming is an instance because that's normally the pattern. And I want to see its
there you can
implementation
just
of action.
No, it's not action.
No,
it's action colon.
Action colon. Yes. Okay.
Yeah, but that's different. So when you select
so I
action,
didn't select the. I didn't select it. You're right. Okay.
Right, and now you're gonna get new other things, other methods.
I'm getting the implementers. I'm not getting just this one. Is there a way to get just that one?
No. So when you're playing with things statically, then you don't know where this message could possibly be because all sorts of crazy things can potentially happen. Like we can, this new method could take the pointer and change it to something else.
Can I ask this class? Like, hey, if I sent one of your instances this message, where would it go? Can I ask it that?
Why not? Now, how would we do it? Like there could be a couple of possibilities here. So one option would be to actually select the text that you want to play with. So in this case, it's going to be this one, and try to debug it.
Oh, okay. Try to debug it. Command D.
Command Shift D, I think it is.
Command Shift D.
Or otherwise, just copy it in the playground and you get it there.
No, didn't work. Okay,
right. So just if you can always just copy it in the playground.
It did something. All right.
Oh yeah, so you did Command D. You didn't do Command Shift D.
I need to make a new playground.
So Shift Enter Enter.
Shift Enter Enter while I'm over here. Oops. Oh,
it doesn't matter where. It doesn't matter.
Oh, I busted it out. How do I bust it back in?
You can't.
Oh, okay. I'll just get. All right.
So
playground.
If you do Shift Enter, it's gonna get you the if you do and then click on the third button.
Debug it. There we go. All right. So I'm in here. And I need to step into, is there a shortcut?
Over, and you're here, right? You're now sending new. So
yes. Step over.
I guess that's not so interesting.
Milliseconds, step over. Step over. Yes. Is that creating the block?
That's creating the block, exactly.
And then this one.
And now into There you go. So now you know exactly where that one is. Right?
Okay,
So
cool.
this would be one way to find this out, right? But another way would be to actually ask the system, because now if I know I want a message that's called action in a BL repeatable task action, something like this. So I could actually be repeated task action. So we could even do, we could actually go and search for things like that. So in fact, I would be interested to get you interested in learning how to search through the system, because that's a powerful, it's a powerful multiplier of your effort. Because once you learn how to search, then you're going to be able to start answering more interesting questions, or asking more interesting questions, answering those interesting questions.
Right.
So I just want to show you maybe where that one is. And we don't have to necessarily go into it now if this is not of interest right now.
Yes, show me where it is.
So if you go on the GT tab, so on the main tab in the book.
Where's book? Oh, in this book?
The book. Yeah. You're gonna have this page and this page.
Okay.
So this is a little DSL or Fluent API that we put together that when you run, for example, if you inspect any of these, you'll see that you get an inspector showing you a filter of, so when you're doing implementers or references, you're actually running one of these queries, and they are also composable.
Cool.
So when you're in, if you take, for example, go to, for example, this one, GT Pragmas, and press Command N.
Command N.
Okay, so that one gets you the references to that one. And so that's a filter, right? This filter actually is the correspondent of doing hash GT Pragmas GT references, and would give you the same thing. And also means that you can start composing them. So let's start with the playground. So now you know where you find it. You can go and read afterwards. So if you want to go this path, then we can write a few just to play a bit with some queries. Just to get that you get a feeling for it.
Okay.
So we were trying to see action : so can you do, for example, right now, hash action : so a symbol action : right? And now we send the message GT implementers.
And then Command G. Boom.
So what you get a filter. So this is not the latest version of GT, right?
No.
So in the new one, this one is
faster,
probably much faster. Like
cool.
So okay, so now we have this, and let's say that now we're actually only interested in those that start with a class which says BL.
Okay, sounds good.
So we can do then end. No, ampersand.
Okay.
So okay, and right, and now you can do, for example, a string, and you say BL. And now GT class matches.
Command G.
Yeah. So now you're looking for this predicate, and you're going to find only those that are in BL things.
Right. And so maybe, is there one for like superclasses of a
No, actually, we
particular
don't have one of
class?
those. No, we don't
No.
have one of those, but that's obviously something that we should add in there. But
Cool.
if you would write there BL repeated, or just repeated instead in the string, then you'll probably find exactly what you're looking for. in this
BL
case.
repeated.
And
Okay.
that was the name of it.
Yes. Okay. So yeah, I mean, it's not a very interesting method. It's just
It's not very interesting. But now let's do something else, because let's
Okay.
do so just to get an idea of what does this composability mean. So pretty much everything that we do on the UI, we first of all do it programmatically. Why? Because we want it the other way around. So every time the UI stops, you want to always fall back to some programmatic level and quickly bridge to some other place where maybe there is a UI where you want to be. So please just copy this part or cut it. Just copy it and delete it. Okay, now execute that query. Okay, and now, so you have a filter over here, right?
Yep.
Great. Now let's take the playground from here. And now you can do self and paste the same text.
Cool.
And now
then,
Command G, right? And that's going to be a refinement of that query that you just had there. Okay, now let's go and do the other one. So let's do the typical or more typical things. So if you go on the first pane, just go where this action is with the cursor, right? And now do Command M. You're going to get exactly the same thing.
Right. And I can then refine it down here myself.
You can go and do whatever you want with it afterwards, right?
Cool.
And that's the interesting thing. So what you see here is that sometimes the UI is not good enough. Right. But then you can, there are always these interesting things is when you start combining them with a little bit of scripting, and then boom, you're
mousing and then code and then mousing. Yeah.
Exactly. Right. So there's this balance between, oh, I like this view. Oh, I don't have it. Oh, let's go somewhere else. And but then I like the other view. And so, for example, let's do let's do a more interesting query here. Let's say, actually, there's not going to be anything interesting here because they're all pretty much going to be setters. So, but yeah. So, I guess, can you expand? Yeah, that's gonna all of them like this. Yeah, so not interesting whatsoever.
Right, but I can change it. I can do another one.
Yeah, so let's do, for example, let's look for what did you want to look at? You wanted to do something like
step. That's a thing that I'd love to see.
Okay, but let's look at references, because those are more interesting usually.
Okay, references to step. That's N.
That step is not.
No.
Yeah, that's N, right? So you look at step references
Antler
there.
Scanner, no. So now I need a real
so there's gonna be
filter.
Right.
Self and what was it? BL class. No, what was it? GT class matches. Boom.
Yeah, GT class matches.
There, the base animation, probably the thing I'm thinking of. Interesting. Maybe step is not the one I'm thinking of.
Exactly, it's not.
Yeah.
But again, like, it's very useful to go in there into those, because you will be able to explore go from a hypothesis to an analysis. Look, quickly, right? So
it's right there. Did it show up?
I know, but this is like an old, very, very old implementation of everything.
Okay. Right. Okay, so then what am I doing wrong in my Atom? I'm not, my animation, I'm not
Actually,
even
I
doing
don't
anything
know.
with it, so it doesn't really matter that I didn't run yourself, which I understand now. I get it, but I'm not doing anything with the animation.
So that's probably the problem, but it's one of the problems.
So then I think I tried something, maybe this is because I wasn't using yourself. Add animation. Let's see. Now I can, what, do I have to rerun this? Oh, that's, what did I change there? Rerun my demo. Ooh. Add animation, no. BL base animation, okay.
So if you look at the right, so you have this NQ.
Is there
If
any
you
way to
if you
see
look
the
at
class of this?
of what?
Oh, a repeated task action. Okay, so it's not an animation.
So you can wait. So
Yeah.
the debugger is also in the same flow, which means that if you're here and you're pressing Command G,
yep. A
you will
repeated
get the
task
inspector.
action.
You get
And
the inspector, so you can inspect from there and continue.
So it's a task. So how do I get an animation from a task? I tried with animations. I looked at all the things that had animation in the name, and they they didn't seem to be what I wanted. So maybe add animation is wrong. I don't know.
Okay, so let's see if we find something.
Where do I go
that is
from here?
maybe more interesting? Let me find something.
Can I see? Oh, I want to see the usages of this again. References N. Live. Morphing world. Boom, boom. All right, let's try block demos. In queue task. Oh. Could try that. Self self and sorry, that's my JavaScript showing. In queue task and animation. It's not really an animation, but I called it animation. Oops. Nope. It's not a BL element. I need to do biz. Boom. Biz. Can I continue from here? Oh, well, they moved.
Something happened there.
Something happened. Oh, okay. Well, that's good. They moved. That's not the right move, but they moved. I have to look at tick.
Right on, Eric.
So I'm doing a transform translating by VX VY at VY, and I'm setting VX VY to be 10 at random. So a number between 0 and 10 or 1 and 10.
But I also see here some translated by 399. I know that's something else.
That is the initial position.
No.
And so I'm assuming, this is my assumption, that this ran or is running, but it's doing the translate wrong so that it gets, and then it went away. It's over here. Is there any way to like know that this is running, that this block is running?
What do
I
you?
would do something like put a print line in it and just watch that the console is showing new print lines.
Oh yeah. Well, you can always do a self halt.
Oh,
So putting a breakpoint.
a breakpoint. So I would do something like
Yeah. Dot.
what?
Say self halt. Yeah.
Self halt. Oops. Like that?
Hmm.
Ooh, why is it red? This is the typical message to use for inserting breakpoints during debug. Oh, okay. Now that killed my atoms? Oh no, I just clicked over there. Okay, boom. So it didn't halt.
But I don't know where you put the. So maybe you don't get to that place.
Right. Oh, maybe that's this one. Oh, that's this line. Sorry. I was just trying to move it to call relocate. Let's try this again. Okay, my fault.
I don't think that sorry had any place in that sentence.
Okay, so all right, let's step through the code. I'm creating 100 atoms. So I'm making Eric Atom new, right? Then I am getting the viz out of them, which is the BL element. It's similar to this one. And then I'm making this one have a viz called it's a rectangle with a rectangle geometry border. That's what's making this black square. That's 400 by 400. And I'm adding all the children that I got here. Okay. And then when I do the run or the demo, it's instantiating it and then calling the viz message, which is passing the viz message, which is just returning viz. So that's what's showing up here, the viz. The Eric Atom.
Wait, wait.
Oh.
Eric Adams. What was the superclass of Eric Adams?
Object.
Okay. Just times Adams. Okay, but that's not, something's not quite right there. I wonder why it works for you. So, because what you're doing there is that you're Adam Viz. Oh, I see. Oh, I see. Oh, I see. Got it. No, yeah, it does work. Yeah, got it.
Okay. And so Eric Atom is similar. It's got a viz as well. It's initializing. It's got a velocity in the X direction, velocity in the Y direction. It's between 1 and 10. It's a 10 by 10 square, red square. And then it does this transform to like put it at a random spot. Okay, this is just one. And then I'm setting up an animation on the viz. And then it's just calling tick on the self, which is doing viz transform do, and then just translating by the VX, VY. And then it's supposed to halt.
And then, of course, but you're never executing. Oh, you are executing because you're putting the NQ task. I missed this one.
So I'm wondering how do I comment this out? Quote?
It's with double quotes, yeah.
Double quote. I just want to comment this line out for a minute and try it again. Okay, so it's definitely that task that's moving them.
Sure.
And the translate by.
You don't get windows popping up, do you?
What is this?
I don't know.
something deep in the UI. Okay. Right, let me try it again. Now it should move. Yeah. So the
But
translate.
wait, just a second. Just a second. Can you go back there? So let's actually go and inspect, because like I don't know exactly what happened here, but it seems to me like something is clipped there, because I can see that
it's a bunch of squares or something in
I
view.
don't know. So actually, let's go and find out. If you look in children, the children view of this one, we should see that it should have 100 of them. And let's see what kind of bounds do they have. So if you click on that line and inspect the bounds, yeah, just double click.
Double click.
Not
Okay.
if you look at that one, it will just show you the rendering of it.
There we go.
And, right. So now in the overview, we should see you see there like this extent, and then you have visual bounds. It's from 0 to 1010 on the right hand side. The third one. Visual bounds. Right. So let's go and see the same for the other ones. Just go and browse on the left hand side.
0, 10, 10.
Right.
So does that mean it's in the 0, the top left corner is 0, 0?
Yeah, exactly. So top left, and then they have size 10, 10. And so that means that they're all right there.
All in the corner. So then what is this bounds in space?
Yeah, that's the one interesting one. It's interesting that it
position in parent 8, 9.
Okay, so that's I'm sorry. That was the interesting thing. The position in parent. Okay, so this is 8,
different
9
in each one. 9, 2.
Right.
So I wonder how it's getting a different position, or such a weird position, because they're starting out kind of randomly distributed, and then I'm only translating them.
Could we give them? Could we just make 10 of them, and give them different transparent colors? So random colors. So let's say 10, and instead of like not in the border, in each atom.
Yeah.
We could give them, instead of red, you can say color at random.
At random. Does that work?
Or just random.
Yes.
Right. And you can put it in parentheses and say alpha 0.5, for example. Like this, we can see if they are overlapping.
Wait, I do.
If you say color random and then pass alpha colon 0.5 to it, it will give you
colon 0.5.
Right. And so you have to put the whole thing in parentheses. So from color to 0.5, because otherwise it's going to think that background alpha is a message.
Right.
So let's see what happens now. I don't yet see the probably into the live view.
So they're all,
this gives you a better.
It's like they're not translating by, they're translating to. Right?
Maybe. I don't know exactly what happens there.
Can I? I don't think I'm calling this method. I kind of feel like deleting it. Can I do that?
That sounds.
Is anybody using it?
So yeah, it is using it. And that's why this is one of those things that we have improved in the last version. So the performance of the way you work with Coder is way better in the last version. So what this one does, now if you're clicking somewhere else, is going to give you a drop down with saying that that there are references to it, right? And then it waited here until it found 276 methods until it showed it to you.
I see.
And
okay, so someone is using it, but I don't.
But you can put a self-halt there if you want.
Oh. Boom. Self-halt. Do it. Save it. Now, come on. Halt.
Let's see. But I don't think that anybody is calling that. I didn't see anything like that.
That's a halt. Okay. All right, but this isn't halting either. So I'm worried, like this seems weird. That
Right,
it's-
that doesn't go, that doesn't do anything. These and Q, that doesn't, I'm missing something. And I
do
don't
I
know what I'm missing.
need the what was it called when we did? Somebody used this. Oh, now I'm lost again. We had a
What?
thing where we could see delay. 500 milliseconds is reasonable for debugging purposes. Okay.
But that just gives you a delay to.
But does that, it's repeated, right? So it's a delay every time, or is it the delay from the first one?
I'm not sure exactly, but I think it's.
Okay, let's go. Boom. So it's not calling this, doesn't seem.
No, it doesn't call that one. That's the thing. And I don't understand exactly what's going on here. Yeah.
It's, I mean, it's got to call tick, right?
That is strange.
Is this one of those things like maybe because I just have it as a, I didn't subclass BL element. I just have one in a slot, and the self is actually on the element.
No, that's
No.
just gonna say what methods, but you can put a self halt in that block if you want. But it still doesn't seem to element these.
Should I have to rerun it, or should that already, if it's running?
No, so when it's a block, block, you have to run it, because like if it's inside the method, then
it's the instances are already pointing to the old method. Is that
no? If it's inside the method, then next time the object will receive the same messages, but the block is already, if you store a block as an instance variable,
got it,
then it's stuck there, and which means that it's no longer in the stack when you're
right
looking, and
but it did get run.
it's already stored somewhere. Yeah, so
And
here
then
you see the tick. No.
Yeah.
Okay. So now you have another one.
But why did self tick run? But if I go to tick,
yeah, but let's just go over.
Halt.
Just step
it
over.
It doesn't have a halt.
Yeah, that's
Didn't we put a halt in here?
Yes, and I was wondering whether you saved it or something, or maybe there was
fault.
some sort of an issue,
and that's
some other issue. No, like the one you've just done now, like when you're just have a debugger and then you leave it somewhere and then we don't know exactly.
Yes. So should I close this?
Well, so you can. The other alternative would be to just go through the execution. So would be to step over here. Not through, but
oh no. Is there a step out?
It's well, yeah, you can click somewhere else and then recompile from there.
It'll halt again on the next tick.
Yeah.
Let's try. All right.
There you go.
So
over.
Call.
No, it was already too late. No, because you had the self halt after the tick. So we need a self halt before the tick.
Wait, should I just get out of here?
Yeah, because it's not going to be particularly helpful here because you're already in the block.
Right. All right. So wait, should I save this one? Is it not saved?
Yes, exactly. It wasn't saved. Yes, it doesn't show the yellow thing.
Okay. Can I test that? Let me try this. Boom.
Yeah.
Save it. And now run it again. This one. That worked. And I am in there.
Yes.
Okay, I hadn't saved it. Okay, that's my fault. I should have saved it. Okay. So it is getting a tick. What is VX? 9 and 6. So that's probably where it's putting it, right? Overview. It was at 195, 380. And then I
Can you
did,
try here to say self? Okay, so you have this V's, that's the transform.
it's already done the transform by though, right? Translate by. It's the whole is after.
Right. Well, so we're back into that situation where we're just trying to do things and we're not playing. We're not creating experiments now. So we're saying, oh, does this code work at all?
Right.
So let's actually take a playground, create a build element, and then try to move it, right? And this would be how we would create something like this. So we would have, you need a container.
BL element. No. Let's try it. Small steps. Wait, Command G. There we go. Boom. Okay. Let's give it a geometry. BL rectangle. Geometry. Oh, new. Background is color blue. And then I need a size. 10 at 10. Then do I need it yourself? I feel like I want to do that now. Boom. Blue box. All right. Now let's make a variable box. Boom. Do I need to put the bars? This seems. No,
What
it's
do you
working.
mean?
Box. Like you do at the beginning of a method for the locals. No, it's working. Now let's try something. Box. Transform do. A transform. A transform. Oh no. Slate by 20 at 20. And then do I need to do anything else? Oh, let's see, that worked. Now I'm going to do it again. Nope. What happened? There we go. Oh, do it. Oh, I need a period. Boom. Boom. Now, was that okay what I did? I recognized my mistake. I closed the debugger and I
Very
fixed the code.
nice.
Yeah, okay. Look, it didn't translate it twice. Right.
So
I want to see this method. This method. Okay, it's calling the block with that thing. Okay. Well, that's not going to do it. Translate by. How do I see that method? I'm going to have to do implementers. Implementers is Yes. Right, because this one was, I feel like I'm back into like reading code.
Yes. So
and not...
implementers will always get you to the reading code, right?
Yeah.
The alternative is to look for.
Oh, is to look for references. Now I'm reading
Yes.
code, but I'm reading code that does that uses it instead of code that
right. It gives you
it.
this one. Can we stop a little bit here, just to interject a bit. So what we're trying to figure something about a system out. The whole premise of moldable development is that this is the primary activity in a software system. When working with a software system, it's not the writing of anything. So, which means that this is the one that should be as explicit as possible and as exercised as possible. And the way we exercise this one is by saying, what is a hypothesis? When I don't have a hypothesis, it's like with research, right? If you don't have a problem, that's your biggest problem.
You just read the next book,
right?
And read the next book.
And it's not interesting, right? It's like you never, doesn't lead to anywhere. So the more interesting thing is formulate the hypothesis and the question. Then after you formulate the hypothesis, you want to go as quickly as possible and do an experiment to validate or invalidate your hypothesis. Sometimes that experiment is functional. Sometimes that experiment is by just looking at the code or structural. Sometimes I want to really look at it. Sometimes I'm going to express it as a test. Sometimes I'm going to do all sorts of things like that, right? So that's the process. Okay, so one of the
so can I say my hypothesis that I think I have? That my guess now, my hypothesis is that translate by translates it from the parent's origin and not from its current position.
Possibly.
That's my hypothesis.
Okay. So then we could either look for something that is to see where it's being used and see in what context that one happens to work. So one way, or another one would be to do some other experiment and then find some other method in BL element, for example, that would maybe do some other thing.
Yes.
Or similar. Okay, good. So one of the things that we left at last time were examples. So examples are like tests, but in that they're executable code. You can have assertions in it or not. But the difference is that here you return an object. So the examples return objects. So and an example is annotated with a pragma, which is called GT example. So because it's now recognizable, one interesting thing would be, could we maybe find exactly, right?
GT, wait.
Right.
Is it GT example? Like that?
Yeah. Yeah.
And then GT pragmas. Oh, jiggle animation sounds like a good one. Jiggle is translate by 0, 51, and random negated. I'm not calling apply. But that's a transform. Wait, oh, now I'm reading code again.
So, but but you're getting into it. So, but there's like something we just learned, right? Translate and animations, they kind of maybe do something together. So let's take a look at maybe the second one. It looks like bouncing chicken.
Bouncing chicken. Yeah, no one's doing this transform do. I feel like that might be, can I search for example.
Can you? So this is an example, right?
Mhm.
Which means you can inspect the result of it.
Oh. You want me to watch a bouncing chicken? Oh, look at him. Whoa. Okay.
Wait, I want to see the bouncing chicken.
You missed it? I'll do
Right.
it.
It misses it. It's missing there should have been yellow
background.
bubbles.
All right.
But, the background is missing. The BL chicken is not the chicken. It's just the.
Yeah, no, it's
But,
I know what you mean. This isn't the whole example. This is just the chicken part.
Yeah.
Can I go to the class? Open. Yay. Oh.
It's missing the background, I guess, in the self chicken, I guess it is.
Well, it's cute. Right. So maybe I don't need a do transform. I can just do element transform.
I would be surprised if that's the problem. But let's go into the transform do now, because now we are armed with the hypothesis, and let's go and find this transform do and then explore what that is, right? So now we want to look at the implementation of it just to make sure that we kind of understand what it is. So if you're selecting text and you're doing Control M or Command M here, we're going to search for that string. If you're just clicking inside it's going to take the AST node. So,
okay. I gotcha. So,
which means it's specifically interesting for keyword messages, because for keyword messages, right, if you're selecting a piece of text, then you can have interspersed arguments there. So it does call apply, doesn't it?
It does call apply by itself, so I don't need to do that.
So you don't need to do it. So that's not the problem. There needs to be another problem. I don't see actually the problem. I don't follow the code, but it's also, I would probably massage the code slightly differently.
But I'm also thinking I don't need the do, right? I'm looking at
you
the other.
do.
I do. Okay.
It's the same. So if you look into what this one says, is that basically says self transform to viz, and then to that one send everything that you send into the block, and at the end of it send apply. That's what it said.
Right.
So it's transform do, and the other one is kind of the same. But you can do this the other way around, right? So you can now say to transform do, and then find the examples in where this one is being used, and so on.
Okay.
Right.
So
if this is the worry, but I wouldn't worry about this specific.
Right, that should be references, right? Boom. I just did the wrong one. But no, I think that there's something weird about translate by that I don't understand.
There's like the clock example has that.
Yeah, and that's where I got it from. That's where I copied this code.
Obviously, that's not the problem. Right. I don't see it right now.
It's obviously setting it to like 9.4, whatever it is, instead of adding it to the current position, which is what I would expect from translate by. I'm wondering if it's because I never set the origin on the viz to 0, 0.
You are right.
It's so default. Oh, I do a transform do, yeah. No.
I would leave this one as an open thing, and we can come back to it at a later time. What do you think?
So the other option is to read more about BL element. That's what I was.
No, what I would do would be to rewrite the code. So find examples that are somewhat interesting. So there, in the previous search, I saw something with animation examples, and And that can be an interesting source of input. In the previous search where you were looking for, I think it's in this, in one of the tabs on the right. That's probably this one.
Yeah, like the
So
jiggle
I saw
animation.
here. So if you click on this one, on the class, you can browse directly in the class. And then in the examples map,
Oh,
so there you have lots of examples here.
oh, examples map. Okay. Ooh.
So these are dependencies, right? So examples, because examples are no longer, they don't depend on a framework. They are, you can call, like an example can just call another, it's just a method, returns an object, which means that I can compose examples by calling them. So you can see how this one over here calls this example here. Which means that if you're expanding that one, just for the sake of it, and then we'll see. Right, then it means you can actually go and inspect the inner object and see how the larger object is made out of it. Right, so these ones are just, okay, this is a BL animation, and then afterwards you're doing something with it. You're adding some duration, and then you're doing something. Saying is starting, is running.
Right.
So you can learn from examples, because they, and especially when they are built upon each other.
Yeah.
Because it's like, you normally, if I give you 10 lines of code, you will tend to read it top to bottom.
Right.
But here, actually, it's much more interesting to not read it top to bottom. So you're going to read these ones first, and then this one, and then the rest of them. So, or just, you know, maybe if you expand the example duration, for example, there, that one, you read that one first, this one is first, and afterwards you're going to read the rest of the text. So it's a different way of reading, and especially when it is applied to, this is an example of how do I set an object up, which is your core problem right now. You're saying, how do I set up an element with an animation that is ticking and that is it eventually doing something?
Right.
It is very interesting because, like, I need to go many levels deep now, and I don't know how many levels deep I need to go because I don't know exactly what I'm doing wrong. So when you're seeing a large dependency in an example, this is an interesting, there's an interesting opportunity. So if you want to see what the result is, you're going to click on something on the right hand side. Sorry, on the left hand side. I don't know how the video shows it, but and then if you want to learn how this one is built, you're going to go from the right to the left. In the graph.
Wait, I'm sorry. I need more brain sugar or something. I've been thinking too hard.
Every one of these is a test.
These are tests. Okay. That's
For
what
example,
it started looking like when I saw these asserts.
Right, but there's a difference there, because it sets an object, right? Writes an assert.
Yeah.
That's a test so far.
Yes. And then it returns.
What differentiates the test from a test, an example from a test, is this. It returns something. Because like a typical test is a void method. So what does a test do? Sets up an object, right? Then it ensures that it has a beautiful property or a set of beautiful properties. So now I have a beautiful object in my hand. And the best thing that a test decides to do is throw it away. And then we say, well, what a wasted energy, right? So examples are going to return that object.
Right. So then you
because
can
I returned the object,
play with it.
You can inspect it, and the inspector is a rich place. It's no longer these dull variables, and then I can have conversations.
Right.
So that's why we don't decompose, we don't write tests anymore. We write basically only examples. And those examples, because when I have it like this, I can also actually take the resulting object from executing this example, and I put it in a documentation if I want to. Right. Or I can have demos like the one with the bouncing thing, but I saw this one, I press a button and I can see how this one moves or does something, because that one is an interesting thing. So that's why, and also then the fact that you can compose examples out of smaller examples, it's a benefit over tests, because I can see what is the logical construction of it. So I don't have a, if I look at the test with 20 lines of code, right. And so if I look at the test with 20 lines of code, I will tend to read it line by line, but I should read it inside out, not top to bottom, because that's the wrong way to read it. So that's the difference with examples.
Okay.
If you want to read about examples.
Quick question, and I know Eric, I don't know what your time is, time constraints are, but there's actually I'm oh, holy cow, Eric. That's looking.
Yeah. We changed the colors to random colors with a 50% transparency while you weren't looking.
If I could get like 5 minutes at the end to get something over the finish line, I would be.
Go ahead. Thank you, Tudor. This was amazing. Thank you so much.
And I would love to hear kind of what
Eric,
you learned.
Eric,
do you have like 15 more minutes, Eric?
Yes.
All right, cool.
Eric, there is in the book, there is a little tutorial about examples. If you want to read about them.
In fact, Eric, would you mind showing off what you and Tudor covered? Because I was actually having a great time. I'll show what I did.
Yeah. So
that's it.
Mostly
I was like gone for 45 minutes, and that's all you. That's all you typed.
Well,
I'm kidding.
Mostly it was Tudor showing me how best to debug. I mean, that's what I'm calling it, debugging, because I have a bug where, here, let me get rid of this halt. I'll show you what it does. And I'm going to remember to save it this time. All right. So if I run my demo, they all move to the left and then they stop. And they should be moving in some line, somewhere. Eventually I'll get the bouncing once they move it all.
Yeah.
But
so they actually started someplace and they all went to
watch it again. Watch it closely.
Oh, cool.
Right. So it's like half a second, and then they move.
Awesome.
Right. And we were wondering, we spent a lot of time, we were wondering why this wasn't getting run. We put a halt statement in there, but I actually forgot to save it. And so it wasn't running because I didn't save it. And I remember that there was like a yellow box up at the top on my other computer.
Disappeared and it has to come back.
Yeah, something happened to that. So I didn't check to see if I had saved it, right? So
I think it's the computer that's the problem.
Right. No, seriously, it was showing up on my other computer. I don't know why it's not.
No, I know.
So then we figured out that this wasn't running. So then we did it. And then it started moving. Well, no, then we were trying to figure out like a good way to figure out what it was doing. So and I didn't show you, this is the color random.
Cool.
I reduced it down to 10 of them instead of 100. And that just helps, like, which is a good idea. It helps see that like they are kind of clumped in the middle, like in the corner there, but they're not all at the same spot, right?
Awesome.
So that was a great idea from Tudor. Like when you're working with graphics, like make things different colors and easier to see. Right. And so another thing to try would be to say 100 at random, just so they would spread out a little more. You'll see. As far as I understand, this will make them spread out a little. Yeah. So they're spread out in the top left corner. So this is 400 wide, but then I just said 100 by 100, and notice it just reset their XY coordinate to some random number between 0 and 100. And I was expecting it to move it from its current location by that random amount, because I was considering that the velocity, like every tick, could just move it a little. So it didn't do that. So it's not meeting my expectations, this translate by method. So we were investigating translate by, and I was reading code, and he was like, no, don't read code. And so I pulled up a playground somewhere. No. Do you remember where it was? Maybe it was over here.
Yeah, just go through. Okay, yeah, exactly.
Yes, I made this playground where I set up an element. I set it up. It's a blue box. I'll run it. Boom. And there, it only moves it once. It doesn't move it the 20. I mean, it moves it twice, but it moves it in the same spot each time. It doesn't actually move it down and down.
All right.
So like if I do this, make it 0, 0, like I would expect this to be like a no op, but I bet it just moves it back to the origin. Yeah. So that means, I mean, that's a good test that translate by does not do what I expected to do. And this is the kind of thing, like what I feel like right now is a beginner closurist, because I see this all the time where a beginner closurist will say something like, well, what happens if I pass this function a null? And I'm like, don't ask me. Pass it a null. Just see what happens. You've got the REPL open right there.
So
and
is this what Tudor meant by don't read the code, just do it?
I think so.
Yeah, that's great.
So
it's really wild.
This is one way to not read the code. Other ways, sometimes you want to describe it differently. So this is a functional decomposition of it. I'm just taking one I have and I'm trying something. Another way was,
I'm sorry, just to make sure I understand. So this is actually kind of a great minimal
failing case.
And of like
experiment
of rendering something.
Yeah.
Okay, that's great. Yeah,
exactly.
cool.
And another one was we wrote a query that kind of used this one, and then we found the examples that are using the same thing so that we can maybe learn from the examples. That's another way of not reading code. I'm not reading the implementation code in this case. I'm going to say, oh, I want to see what are the interesting things. And then I'm not even going to read necessarily the examples. I'm going to run the examples, find one that is kind of interesting, and then I'm going to start reading. So
cool.
Different strategies to decompose the space.
And the other strategy, I think, would be like, well, I know how to do something, so I'm going to set this up myself. I'm going to make my own X and Y. And then I'll be happy. Okay, now I got to make a slot, add slot Y, add slot X, cool. And then translate by X at Y. And then here, I want to do two things. I want to update.
You should save, but.
Oh, thank you. All right, I want to do two things. Or three things. X equals X plus VX. Oops.
Oh.
Y colon equals Y plus Y. And then translate by.
Here's a man who doesn't trust do it himself.
What do you want me to do? What?
Oh, no,
yeah. Well, I don't know how it works, so I want to try this. I think that should work. Oops. Plus was sent to something.
To Neil.
Yes, it's moving.
Yeah. And they all left the screen.
Yeah, well, they're all gone too far. Let's see. I want to make it faster, so I'm going to do 20 milliseconds. And try it again. Whoop, bye-bye.
That's great, Eric.
Now I just gotta make them bounce.
Oh, that's really great. I'm gonna copy and paste that. Hey, and before I grab this show where I got to, any reflections?
A lot to learn. That's what it feels like. I mean, Tudor's doing a great job, but it's like I make 2 steps and it's like, whoa, no, wait, don't go there. I'm like, oh, okay, I gotta learn I gotta learn that too. Okay. So
By the way,
thank you
from my
for doing
perspective,
that. The patience.
it looks great. It was really flipping awesome. Nice job, Eric.
Thank you.
I feel like I'm going to show off what I did, and it's going to be grotesquely embarrassing.
Well, I want to see it. Can we switch?
Yeah. Hey, by the way, Tudor, Eric, thanks for doing this with me. This is so fun.
Thank you, and thank you
for me. This is really cool.
Yeah, thanks for your patience and everything.
So what I wanted to do was I have a big JSON file of tweets, and I was inspired by Tudor's numerous videos where he's showing how to view that. So I saw the I got well, okay, let me show you. Unlike you, Eric, I got bitten a couple of times editing code in the GT editor, so I'm using this. So I built up GK tweets. And so I made a message to load up a JSON file. How did I do that? Honestly, can't remember. Oh, yeah. Oh, so I learned how to load in a file and then read it as a JSON file. And then
Why don't you run us through all of it?
I'm sorry. Oh, you want me to run you through all of it?
I don't know.
I'm sorry. It was.
If you want to.
Again? Yeah, of course.
I think it would be easier also for Eric to follow.
Okay, yeah. So okay, so I load in a JSON file, and this is basically the Twitter history. So I just grabbed the whole thing, and I specifically filtered them for things that have an image in it.
Okay.
And then there's this thing to see if you ask it whether the file exists. Obviously, I couldn't find it before. I read the stream, and I'm converting it to JSON from the stream. And so I'm just going to click into one of these and go to tree view. You can see the status, the retweet count, and then under entities, there's a media thing, and then it's a kind of an array, and then there's a media URL, which is what I want to go ahead and grab. So then I made one of these new GK tweets. So Eric had an Eric, what did you call your class?
Eric Adams.
Eric Adams, one of those GK tweets.
Cool.
And then passed it a tweets.
Inspect it.
Oh yeah, thank you. So what's in here? It's right. So I made a tweets message so I can pass it to JSON object. And which is what I call here. So somewhere I should be able to see. Interesting. Where do I find the
slots?
Yeah.
The value, not the. So that's.
So, sorry.
So
Just because the first image, the slots. So where is that? Meta.
Go to meta.
Thank you.
And then click on that. Yeah.
Whoa.
Class
you
bars.
see, but that's a class variable. It's a class variable. This is not a slot.
Oh. Okay, let me confirm that. So in my initial.
Yeah. Click on the class again.
I'm sorry.
right? So you see, you've
Oh yeah, I
added
made a
the
class variable name.
names instead of instance variable names.
I did that
You
for
can
a
just
reason.
copy it from here and put it there.
Yeah.
I don't
Okay.
think there's a reason. I would delete it from here.
Okay. Actually, one of the things I was starting to get hung up on is like, all right, I'm passing an array. How am I going to navigate through the tweets? So I think that's why I put it in the class instead of the instance, but I just kept going. So, okay,
Right,
I'm going
so
to
this
recreate
will
it.
not be refreshing.
Yeah, so I'm going to create a new one. Slots. Okay, there we go. Thank you. So then I passed the JSON file to the message tweets.
So now you see it in the raw, right? So if you look in the raw.
Yeah, right. 500 items. Okay. And then I made so then I started going through the, just walking through the process of give me the first array element.
Okay,
and then,
so
yeah.
I would like to suggest something here.
No, please.
It's already impressive how you got to this point. I think it's very cool. But there are a couple of helpers that you use to get here.
Okay.
So in order to understand what you wanted to do here, so entities, media URL, those, right? You went into where did you go? I think you probably remember it from when you inspected it. When you inspected which one? You inspected this one.
Yeah.
Right? When you inspected that one, that's how you remembered it.
Yeah. Right? And I actually did open this up and
or you open it. Okay, so that's fair. Okay.
Yeah.
So you open that one there.
Yep. Entities, media. Yep.
Great. But now, right now, you are, this information over here should be here.
Yeah. Yes.
So whenever you feel like I need to dive into, I'm looking at my object. My object wants to tell me, or I want my object to tell me what is interesting about you. If I need to go and dive into something, many times, especially at the beginning, many times it's just a sign that you're missing a view in that object.
Oh, totally. In fact, by the way, and this is what I meant by, I call it GK tweets, and I was thinking, do I need to create a GK tweet that is the collection of the things? And then I just said, all right, I just want to display an image. But yeah, so that was on my mind.
Tweets, right? And first of all, and you will see how that you will want to create one, because otherwise you won't have where to put the thing. So
right.
When you want to put the
sorry, just a little aside. And Eric, this is where I was thinking, like, oh my gosh, I don't want to start copying getters and setters, right? This is like I think Rich Hickey would die. Right? So I can't wait to hear where Tudor is going with this. Thank you.
So the simplest thing we could do is we can put this one right here.
Cool.
This view.
Yeah.
Just so that when we play with it, I have everything is right there. I don't necessarily need to learn where else do I go to dive. I don't want to dive through things. Because every time I'm diving through a raw view, if I'm looking at the raw view twice, right, the third time I'm doing something wrong.
Oh, in fact, just so you know, like in the background, for exactly the same reason, I had this up, this closure window, so I could see at least in a better view. So yeah, so tell me, how do I do that?
So right now, right, you would go to GK tweets and you would create here in Meta, you would define a new view. So we would create a new method here.
Okay, create a new method. Ooh.
Can you just scroll just to the left, just to make sure that we have everything that we, no, all the way. Okay,
new method.
Yeah. Right. Okay. So let's call it. I can dictate if you want, or or I can show you where to learn from.
Why don't you dictate? Yeah, whatever you think is more efficient.
So view 4 :
Yeah.
Okay, so we typically name them blah, blah, blah for, okay. And then after that, you need an argument, and the argument is called a view.
Nice. Oh, this looks familiar. Yeah. Uh-huh. Yeah.
Okay, and then we have here, I need the pragma GT view. So angle bracket GT capital V view, right? Angle bracket, right? So that's an annotation now. And I'm going to have a return, which is a caret. Return a view. And I will put there a column list. No column, no. Just a view is an object, so right, space.
List.
And now I'm going to pass columned list.
Columned list.
I want 2 columns here. It's going to be not capital C, it's just small caps. Columned list.
There, okay.
Yeah. Enter. And now I'm going to give it a title. I'm going to say title, colon.
Sorry.
Title, colon.
Title, colon.
Yeah, and now, I don't know, raw data. It's a string, of course.
Okay.
Okay, and then semicolon, because it's a cascade.
Okay.
And then I'm going to say, what items do I want to put in there? So items.
Ooh, uh-huh.
And then colon again, and that's going to be a block, so it's lazy.
Uh-huh.
And I think it's called tweets. I forgot.
Yeah. Tweets raw. Yep.
Right. Okay. And then after the block, you put another semicolon. And now we're going to define yeah. Okay. And so now you're going to do here column. Sorry, I always have issues with yeah, column. And now let's say property, the string. Give it a name, right? So you define now the 2 columns. We say I want a column list given this input, and the first column is going to be named, let's call it property, so string.
Uh-huh.
And then and we're going to give it a text. So column, text, colon.
Sorry.
Text. Just type
the
word text.
Maybe
text, colon.
Yep.
So that's now you have a single message here. Colon, text, colon is a single message.
Got it.
And so there we're going to put it's going to be a block for every element in your tweets raw.
Okay.
And then in there you're probably going to have key, because it looks like there's an association, an array of associations here.
Okay. Yeah. Can you take me over the
Can you
finish
put
line?
hash key?
Hash key. Oh. Yeah.
Hash and then key. After hash, you should say key. Okay. Okay. Don't just say accept this one. See what happens.
Okay. And if there's a more efficient way to do this, let me know. Yeah. Okay.
So you see it appeared here.
Oh no.
Right. So okay, like it says here. Okay, dictionary didn't understand key. Okay, go meta.
Yeah.
So it looks like tweets raw. Actually, can you select tweets raw and command G it?
No way. Okay.
Okay, but that's a
This is an array of dictionaries.
It's an array of dictionaries. Okay, in that case, we don't need that. We're just going to say a list here. Instead of column list, we just put a list. I'm sorry, I was a mistake. Yeah, not a capital letter at first.
Roger.
Right,
Okay.
and then delete the column because we don't need this. It's just going to be items, and that's it.
Okay.
And without the semicolon.
Okay.
Okay, now accept it. And go back to your raw data.
Hey, all right.
And then you have it. So what this means, and of course you want to massage it a bit more here.
Okay.
But what this means is that now I don't need to
Yeah.
dive deeper.
Got it.
And then of course, now the next thing you want to say is that, of course, I don't want to see the raw data all the time. What I would like to see here is I want to see tweets, right? I want to have a view that shows me tweets.
Can I?
No, that doesn't make sense.
I just want to see the first element. Oh, can I turn this back into a?
Yeah, if you want to see the first element, but wait, because that's where it becomes maybe a little interesting.
Yeah.
So let's transform this one, or let's leave this one as it is with the list and without the one at one. Just the tweets raw.
Yeah. Okay. Got it.
And then instead of this, now what we would like is I want to now click on the first one and just see that one, right? And that's when the moment when you're actually starting to say, I want to say a tweet, right? Because it's going to beg. So what is the first element? Is a tweet. So I'm going to need to find that one. So let's quickly go to Meta. But
actually, before, I'd love to use, can I show you how far I got, where I got stuck? Because I will definitely work on this.
Good.
So I loaded up the tweets JSON.
Very nice.
I managed to write the first image URL.
Yeah.
And then I want to actually just get to displaying the first image. And this is where I had a problem. I probably spent about 20 minutes on this. And I realized, I think I copied and pasted the code that you gave me. Doesn't quite work. So in this GitHub example,
my assumption is that you're probably trying to JPEG a PNG or something like this.
No, it turns out the avatar URL display wasn't quite right that you posted in Slack. So here's the avatar URL. And this statement doesn't work for your example either. And I was just trying to figure out how do I,
it must do, because it does work for me. So if it's the same.
But this is you. This is your org. Or maybe it's
no,
avatar URL.
Yeah, but it's I think the URL was with, wasn't it with Girba?
Oh, yeah, you're saying it's not
I think one is a PNG.
Damn. Okay, no, that's great. That's great. Okay. But then I know that this is, so then I try to just step through the case. Here's a JPEG. And it's not.
So that one seems to, maybe there's some sort of encoding that we don't know about, but that doesn't happen. Can you just split the two? Just split the two, just put the Control Enter after the first line and just.
I can do that. Oh, cool.
Yeah.
Okay, got it.
Okay, and now Command G.
Yeah.
Okay, so we have the bytes array, so that's fine. So we get everything we need, and then if you inspect that one, it's gonna break, right?
Yeah. So then I brought it up.
That is funny. Okay, bytes. This should work. So obviously it doesn't understand something in the format of that.
Got it. So let me.
That picture.
I'll just go through some. I'll try to find a valid a JPEG file that doesn't do that. So I guess I can imagine Tudor. So if I create a GK tweet, then wait, where was it?
There.
Right, then I could create a viewer.
Don't select. Don't select code.
Oh. Okay, did I not?
You probably
for tweets.
Yeah, it doesn't have now because you instantiated it again. So Probably this one and this one should be in the same place, probably not in two different places.
Got it. Okay, so I could create a view that actually renders the image that's actually in the tweet.
Yes.
Yeah. So
for a tweet, right?
For a tweet. Okay, got it.
Yes. And you will see, but the thing is, like, before you go and construct, so this one here, right? You took the first one, and after I took the first one, I took something from that first one, and then I showed something inside there, which in some rare occasion you might want to do it, but you generally want to build your way to that place, right?
Yeah.
Until the moment you got to the image is probably also going to be an interesting object. So tweets is an interesting object because that's where you're going to put the view with the feed, right? A tweet is going to be an interesting object, and a tweet is going to have an image, and then an image is also an interesting object.
Okay.
And you're going to build your way like this.
Awesome. So anyway, Eric, that's what I was doing while I'm going to listen to you. I'm going to watch that thing. Hey, I got to tell you, Tudor, this is I feel good about the progress. So although like Eric, kind of grinding away, just trying to solve those small problems. Eric, do you want to? I propose. Do you want to schedule another time to do this? And
yeah,
to do.
Can we do?
Say a week?
Yeah, next week is good. Let me check. Yeah,
same time.
Same time.
Right on, Tudor. Hey, I appreciate you doing this, and no problem if we just I'll just record. I'll just take the video, put it to YouTube just like before, and post it.
Right. This is going to be even embarrassing, nicely embarrassingly, because I didn't know how to debug that thing yet. But I won't be able to sleep well now. So.
I'll be sure to download the new version. Should keep it up.
It's not going to help with this problem, but yeah.
Awesome. So yeah, I said, what are my reflections? Eric, I'm not sure if you noticed this, but I noticed this when I was trying to get a MySQL drive. Oh,
I got the bouncing.
That's freaking awesome. Eric, I got to tell you one thing that I did notice. I tried to get a MySQL driver working, and I was using this garage thing, whatever. I was surprised that code and the JPEG code both use native Smalltalk to crack open the images to do the TCP/IP networking. I mean, it's really something else. It's like to see how much code is written natively in the Smalltalk image. That was cool and unexpected. So when you saw the JPEG load error, that was you could see all the Smalltalk code that was cracking open the byte stream. And I'm pretty happy that I can sort of see a route to get to a JPEG viewer, in the tweets. So, all right.
One of the interesting things that maybe you want to try would be that when you get an exception to just display a red rectangle or something like this. This would be an interesting exercise.
Oh, okay. Yeah, great. Good.
Okay,
all right.
So let's continue.
Eric, Tudor, high five, man. That was awesome.
Okay.
All right.
Thank you so much, Tudor. Thank you.
May I distill some lessons?
Oh yeah.
Yes, please.
So I've been looking at how you're working with this and where you get stuck, and it's one of those we do, like, whenever we can, whenever people allow us to, then we do watch people play like this, but it's not very often that newcomers allow us to do it. So it'd be it's a very super instructive thing, and of course we know it is like that, but it's just we don't always find people that are willing to do it. So this is one, and it's super useful for us, right? So when I see that, I get stuck with creating a class, right? So that's obviously a big fail from a UX perspective, and it just distracts people. Like we want to teach some maybe a generic lesson, like people can maybe take it somewhere else, but we don't get to do it because like there are these little things in between that prevent people to get there. So it's quite cool.
I'm not sure if this is an offer or a request. I actually sort of like Eric. I'm kind of rubbing against some of the sharp edges on the GT side, which is the reason why I'm using the Pharo system browser for something. Would it be useful if I just record these sessions? I'll just talk out loud, and like whenever I run into a situation where I'm like, ah,
Absolutely.
it's like
I'll do it too,
I'm
yeah.
stuck. And
I'd love to do
I'll
that.
send
I'd love it
privately. Yeah.
I would love it. Yeah.
Okay, perfect. I'll just do that. I'll just make a habit of doing that, and of course I'm
Super cool.
I'll post it to you and a link to it, and I'll even maybe try to edit it down, or maybe
don't bother.
Okay.
It's okay.
Just watch for the waveforms of like.
Yeah. Yes, exactly.
Yeah. This is great. Actually, Eric, sorry we were going long. I know it's getting late there, but actually, I'd love to hear you as you think about. I'm trying to think about categories of problems that I want to use GT Smalltalk to solve. There's actually one of the things I'm finding is like it's so hard to write a program that it's like pops up a dialog box, asks you something, and just do something, right? So already which is the reason why I wrote the heading down this Twitter rank. So that's like one category problem that I'm definitely kind of just in my head saying this is a good tool to solve with.
Yeah.
I'm not going to write a Clojure script application and react to like I barely know how to make dialog boxes. I mean, it's just like it's so hard.
Yeah. Sure. I mean, I feel the same. Like, I mean, with all the trouble I had, this was still like light years easier than like writing a swing application and like learning how to draw a circle. And I've learned a lot, and so I know the next time it's going to be way easier. So I'm looking at the code, and it's like one screen of code, and it's doing all this stuff. I mean, I think it's amazing, and I'm probably even doing it in a really like inefficient, bad way. Like I'm sure someone would be like, "Oh, there's like a method to do this one, a method to do that," so it's really like a two-liner. I have to tell you, this is the first language I have learned and played with in years now. So it's rusty for me to like learn a new thing. And it's also this very live paradigm. It's a lot more visual than the REPL is. So I've got a lot of practice working in Clojure and in even Common Lisp at the REPL, and you're working mostly with things that they're very data heavy. So you're mostly like, oh, let me just print this out and see the data and try to inspect it. But I really appreciated when Tudor had the really cool idea of like, okay, reduce the number of atoms, change the colors so that they're all random, they're all different. And then like that kind of visual thing, like it's the kind of thing I'd love to do, but like, you can't do that. And I'm sure that Glamorous Toolkit has all sorts of like visualizations, like histograms and stuff, like that kind of stuff. I'm really looking forward to like, I have an array of data, or I have a bunch of things, and I just want to like quickly see a histogram of how some slot is distributed. I'd love to have something like that, and I can't wait to get there. I don't have a specific example right now, but it's the kind of thing that's really hard to do in Clojure, because you're basically just dealing with like print statements. And at the end of the day, it's hard to get a real visualization.
Awesome. By the way, let's end the session by you showing off your bouncing atom.
Oh, you want me to show it again?
Yeah,
Okay.
totally. Yeah, it's like really inspirational.
All right.
Come on, man.
There we go.
Gotta show it off.
Got to show it off. Okay. So I'll run it again because I was kind of changing the code. So there it is. They're random velocities, and I've got a thing. So this is just kind of the container, right?
Oh my gosh,
clicked it.
that's
Delete that one. Oh, it's going to take forever. Shouldn't have clicked it. Freeze and everything. All right. Yeah, they're still going.
oh,
Right?
there we go.
They're still moving. No. Run it again. All right. So right. So I remember I have this tick that runs this do transform, and you pass it a block. Well, that block was getting kind of big, so I just moved it into a method. Probably could have done that a better way. It's probably like a refactoring, like extract method or something, but I didn't do that. I manually did it. All right, so now this is doing all the math. So it's basically saying, okay, add the velocity to the X, add the velocity to the Y. And then now we got to get some stuff. Like we have to figure out the viz is the BL element. And so we need to get its X size and its Y size, right? And then, all right, so we actually use that down here. So not yet. So if X has gone to the left past the box, then we're going to negate the velocity. So it's going to bounce. It's going to start moving the other way, and set the X to 1. We don't want it to be 0 because then it'll just kind of bounce, like jiggle there. Same with Y. Bounce it off. I get the parent bound so I can figure out the right and bottom. And then I do the same kind of math, but because I'm looking at the left-hand corner, I gotta subtract out the width. And so this would actually be viz X. Viz X.
So it bounces when the edge.
Yeah.
Yeah. Oh.
Oh, it's fancy.
Oh wow.
And then I do the same thing, except I have to subtract that back out, I think. Yeah.
Actually, that was a genuine question. And this is just so that the bounce happens only when the edge hits, not the center.
Right.
Yeah. Wow.
or the left edge, because then it would go off the side before it bounced.
Right.
But that's just a tweak, because I looked at it and I was like, oh, I've done some like game programming, so that's kind of like very common. And then it does the translate by with the X and the Y. And
nice.
So that's it. That's the only difference.
Cool. So we'll just cut everything from the video except for the end. And you're like,
look, I did it. But see, that's the thing, is I feel like I was stuck, and Tudor unstuck me, and now I can just kind of play with the code. Like, oh, I know how to write some code, and I wrote the code. And like, I even was like, wait, what is it called again? If true. And I searched for it and I found it in the references, and then saw some examples. I'm like, I can do that. So yeah, I feel unstuck.
Flipping awesome. All right, cool. All right. Oh, hey, have a great evening, gentlemen. This is super fun. I've had a super strenuous day, and this is like, I am wiped, but
I'm
energizing
wiped
still.
too. This is hard.
Awesome.
Great.
Thank you
Thanks.
all. Catch you in a week. Thank you again.
See you next week.
Thank
Bye
you.
all.
Bye.
Bye.